Hi, my name is Koen Van Hulle and welcome in my session about SSL certificates. I'm born in Bruges, a lovely town in Belgium. Today you can find me back in Ghent, another lovely town in Belgium. I'm a FileMaker certified developer at Listerius, where I am responsible for our hosting department. You can find me back in the FileMaker community as an MVP. Welcome to my session. In this session about installing SSL certificates in your FileMaker server, we will follow the fictional company ClipFactory, who invented Clippy, the first internet-connected paperclip. If you're an in-house developer or new to the FileMaker Claris platform, you'll probably recognize the story of Emma and Erik. Meet Emma. Emma is contract manager at ClipFactory. She is very excited about the Claris platform and works closely together with Erik. This is Erik, problem solver. Together with Emma, he designed an app to manage the closed deals and contracts. This application is made in Claris FileMaker Pro and should work for Go, WebDirect, and Pro. It also has a connection with Claris Connect for a flow with DocuSign. Erik is proud to present his application to his boss. But Erik had also to take care of the FileMaker server, and he was completely inexperienced in this. During his exploration, he figured out he had to install a custom SSL certificate on his FileMaker server. And this must be the hardest part in the setup of the FileMaker server. I guess every week there is at least one question about SSL on the Claris community. Why can't Claris Inc. just make this simple? Why is it so difficult to install an SSL certificate? Why does it not work properly from the first attempt? Let's try to find an answer in this session. Before we dive into the process of installing an SSL certificate, let's find out what problem TLS in fact solves. TLS stands for Transport Layer Security. SSL is in fact the old term. So what problem does TLS SSL solve? If you think of TLS, most of you will think on encryption. But this is only a small part of the problem that TLS is solving. So what does it actually do? First of all, it validates the identity of a server or service. It encrypts the content of the communication, it verifies the integrity of the communication, and it verifies the authenticity of the communication. So, if we look to the validation of the identity, in fact, we want to find an answer, or the user needs to find an answer. How are we sure that fms.theclipfactory.com is owned by the ClipFactory? Who can assure this? That is not a scam. That validation is guaranteed by a certificate authority. That's the one that is issuing the certificate. So a certificate authority is always a trusted third party, must be trusted by the owner of the certificate, but must also be trusted by the receiver of the certificate. Certificate authority is part of the CA Certificate Authority browser forum, which defines the rules for a certificate authority. So he cannot decide on himself to be trusted or follow his own rules. So that's why a self-signed certificate that is not issued by a certificate authority can never give the same guarantees of the validation of the identity, because you are not a certificate authority, and Claris is also not a certificate authority. That's why the standard built-in SSL certificate you receive while installation is only for testing purposes. If we look to validation, we have three levels of validation for a certificate. First of all, there's a validation on the level of the domain. There's a validation on the organization, or a validation which is called the extended validation. If we look to the domain validation, these are the cheapest SSL certificates you can buy, because the certificate authority only checks if the domain is valid. So in your certificate you will not see who is the owner of the website. Validation, for the validation they make use also of the whois records of a client. As a user, I cannot check the ownership of, not always check the ownership of the domain, because since GDPR, we cannot see anymore the natural person who is owner of a certain domain. Second kind of validation, which are more expensive, are the organization validation certificates. In this case, the certificate authority not only validates the domain, but also your organization. So it does a verification in depth, and for this you have to give all kinds of proofs and papers and maybe a phone call. Third possible validation is the extended validation. It's almost the same as an organization validation, but the validation go even more in depth. So all company details are also mentioned in the certificate. And in case of abuse of that certificate, you get a bigger financial compensation. So depending on the policies of your company, your FileMaker server should have a domain validated SSL certificate, an organization validated certificate, or even an extended validation certificate. You will see that a big part of the web shops online will have an extended validation one. In the past, the browsers marked this one as a green certificate. Let's go into detail about the trust aspect to better understand how TLS is working and what we exactly need. Just as in the picture, Eric has to trust his partner. If he can't trust his partner, the rope is worthless. So let's have a look to a default installed FileMaker server with a self-signed certificate. If we look to the chain, the certificate chain, we will see one certificate, and it's not trusted. Why is it untrusted? We did not mark it as untrustful. It's by default untrusted. So who decides this? Does it mean Claris is not a trustful company? Let's have a look to another FileMaker server. A FileMaker server where there was an installed SSL certificate, one that was purchased. Now we see three certificates, and they are trusted. Why are this one trusted? What is the difference between them? And why do we have three certificates? Let's find an answer. Meet Emma. Emma is the colleague of Eric. She is working in the contracting department of the ClipFactory. Clippy will be sold in the Apple stores, and she will arrange the contract with Apple. And this is Jack. Jack will sign a contract with Emma. But wait, does Jack have the authority to sign the contract? How can I trust him? So he comes back to Emma and say, here is my proof. It's signed by Eddie Q, Senior Vice President of Apple. I'm allowed to sign it. Okay, says Emma, but who is Eddie Q? I never heard of him. How can I trust him? So Eddie Q on his turn comes also with a proof of authority. Look, this one is a certificate signed by Tim Cook, CEO of Apple. And the last one in the chain says, hi, I'm Tim Cook. I'm the CEO of Apple. Here is my proof. I signed it myself. So Jack gives the proof of authority to Emma, the three certificates. Oh yes, thank you, Jack. I know Tim Cook. Tim Cook is your CEO. I trust you know. Let's talk about a contract. So she can start negotiating about a contract because she is now sure that Jack is able to sign a contract on behalf of Apple. This is what is called the chain of trust. And exactly the same mechanism happens with TLS and SSL certificates. So we have 3 certificates. The root one is the one that is signed by Tim Cook, and with his root one, he can sign an intermediate certificate. That intermediate certificate is used by Eddie Q to sign the certificate of Jack. And Jack doesn't sign anything, he just gives his certificate to Emma. If there's a chain of trust, there's also a chain of distrust. If you don't trust Pontius Pilate, you will not trust Judas, and you will also not trust Jack. Same happens, in fact, with a self-signed certificate. If Jack would sign his own certificate on behalf of Apple and say, look, this is my proof, I've signed it myself, Emma would not trust him at all. So we have seen 2 partners in there, a root and an intermediate. There are root certificate authorities who have a root certificate, and you have intermediate certificate authorities. If we look into the market, we have as an example DigiCert. DigiCert is a root certificate authority because it issues root certificates. But it also issues leaf certificates signed with an intermediate one. So they are playing both roles. But on the other hand, you have also a partner like GeoTrust, who also issues SSL certificates. They issue that SSL certificates with intermediate certificates signed by DigiCert. That's why you can find your local hosting provider that sometimes issue their own certificates. Are they a root certificate authority? Probably not. But they are signing the certificates with an intermediate certificate signed by the root certificate. So let's have a look to the details of this. So if we're going back to our chain, you will see that we have here a root certificate coming from DigiCert. This one was used to sign an intermediate certificate of GeoTrust. So this one is signed by DigiCert, but is owned by GeoTrust. And now we have the leaf certificate, the one that is issued for a certain server. Yeah, this one was signed by GeoTrust and given to the company that owns that domain name. But Emma's smart. But hey, wait, I never trusted these certificates on my machine. How does it happen that my computer just say, yes, I trust this certificate from this certificate authority? Well, root certificates are pre-installed on the client and the server. So it's part of your operating system, could be part of your browser. Certain browsers have their own certificate store, or could be within applications. As you will remember in FileMaker Server 14, only a limited number of root certificates were allowed. These were baked in FileMaker Server, and only this one could be used. So in the operating system on a Mac, you will find them back in your keychain, and you can decide to trust these certificates or distrust these certificates if you don't believe that DigiCert is not trusted. On Windows, you find it in the Certificates Management Console, under the subchapter Trusted Root Certificate Authorities. And in this place, you can add and remove new root certificates manually. That happens, for instance, by your IT department. It could be that bigger companies have their own certificate authority, so only for internal purposes. And that root certificate must be installed on your server and on your clients. So that will happen automatically. But it could be that certificates have it could be that the certificates are sometimes distrusted by, first were trusted and later on distrusted by certain software. For instance, Google at a certain moment decided not to trust SSL certificates from Symantec anymore in their Chrome browser. Your operating system was still trusting it, but not your browser anymore. So the maximum validation period of an SSL TLS certificate is around 2 years. That's why you, in most SSL TLS certificate authorities, you can only buy certificates that are valid for 2 years. But this is going to change very quickly because Apple announced that from the 1st of September, they will no longer trust, or Safari will no longer trust, certificates that are longer than 1 year. And not only Safari will do it, but also Google Chrome will join Apple's rule. So in fact, even if your operating system is trusting it, you should in fact replace all your certificates before the 1st of September if they have a longer validation period than 1 year. What does Erik need to be able to buy an SSL certificate and install it on his FileMaker server? First of all, he needs a public domain name. A public domain name that you own, that the company owns. You cannot buy an SSL certificate for a domain name that does not belong to you. You also cannot buy an SSL certificate for a domain name that does not exist. Second, he needs a FQDN, a full qualified domain name. That's the name of your server. As an example, his server will be called fms.theclipfactory.com. He needs to have a completed whos record of that domain. If you buy a domain, you have to fill in a whos record that is complete. If your whos record is not complete, it could be that the certificate authority will not issue a certificate for your domain. Depending on the kind of validation, domain validation or organization validation, you will need some other things as well. Like for domain validation, you need or a DNS server, or a web server linked to the FQDN, or an email address that starts with hostmaster, postmaster, webmaster, admin, or administrator to be able to validate. For organization validation, you need a proof of existence of your organization. Often this is a phone call and some documents like DUNS number and so on. And next to that, you need a FileMaker server, OpenSSL, or another SSL tool to be able to create the sufficient documents. Let's go through it step by step. First of all, what does the FileMaker server need? The FileMaker server needs a signed certificate file. This is our leave certificate. This is the certificate that you receive when you buy a certificate from the certificate authority. Second, you also need to provide the intermediate certificate, a DQ, as you have seen in the previous chapter. So in this case, we have to upload our intermediate certificate. And what is resting? We see a private key and a private key password. But what is a private key? A private key is a simple text file. The private key is used to create a digital signature. And it secures and verifies the connections used by your certificate. Yeah? And it is also needed to generate a CSR, a certificate signing request file. So what is a certificate signing request file? Well, normally if you want to generate an SSL certificate or a certificate, you will need a private key. But a private key belongs to you, so you should never share it with someone. And to be able to let the certificate authority create that certificate for you, you in fact create a certificate signing request. So it's a simple file that contains the request. So it contains the common name and some other properties, the organization information, if valid, and a public key. And that public key is generated by the private key. And with all this information, the certificate authority is able to generate your SSL certificate. Eric is prepared and can now start buying an SSL certificate and installing it on the FileMaker server. To do so, he needs to follow 4 simple steps. First step is create a CSR, certificate signing request. Then he has to order the certificate. Then he has to wait until the validation happens. Then he receives the SSL certificate and installs it on the FileMaker server. Eric will now generate a certificate signing request. To do so, there are a number of tools. The first tool is the FileMaker Server admin console. Via the command line, he can generate a CSR by these 2 commands. The first one is to generate a CSR for a domain certificate. In case of an organization certificate, we have to generate more information. And you will see that next to the name of the domain name, you also have to provide information of the organization. If you have not already installed your FileMaker server and are just in the preparing phase, you can generate a CSR on your own machine. In this case, I show you how to do it with OpenSSL, with standard installed on a Mac OS, but you can install it on a Windows machine as well. So the command to generate a CSR file via OpenSSL and the command line is the following one, where we point out the name of the private key and the result of the CSR file. You will see when we execute the command, we have to provide some information. We have to provide the name of the domain name and some information about the organization. And we have to provide a password for the private key. A third way to generate a CSR is in the Internet Information Server of Windows, of your Windows server. To do so, you go to Server Certificates. On the right pane, you choose for Create Request Certificates. You fill in the same information. Now you have to obtain these certificates because they are now installed in the Certificate Manager. You will see a chapter that is called Certificate Enrollment Requests, and here you can export them. Now you will end up with the correct files to upload to your certificate authority. Eric has created his CSR file. He will now buy a certificate. To do so, he goes to a website of a certificate authority and have to upload a CSR file. If you have to select server software, choose for the other option. That will give the right format for the SSL certificate as outcome for the FileMaker server. There are also some websites that generate the CSR and the private key for you. I would recommend not to do it, because at that moment the private key is no longer private and is known by another entity as well. So it's best to generate it on your own machine. It could be that during the installation or during the request of buying a certificate, you get a strange error. An error that is called pre-sign failed. Why does it fail? Or why could it fail? Well, you could protect your domain to only allow certificates from a certain certificate authority. So you can define that your domain name could only buy certificates at Sectigo. If you then ask a certificate and another certificate authority, it will be blocked. And how is this defined? It is defined on your DNS server in what is called a CAA DNS record. So how do you solve this issue? You buy your certificate with another certificate authority, or you add your certificate authority to the CAA record in your public domain, DNS. Second issue that can happen, and it happens most of the time in internal organizations with internal certificate authorities, is the feedback that the SUN extension is missing. What is in SUN? The reason you get it is because there is a missing SUN extension, logic. And how do you solve it? By generating a CSR with a SUN extension. Before we go into showing how to do this, let's first explain what is a SUN extension. In fact, if you were on a certificate authority website, you have seen that you can have the choice between domain validation, organization validation, and extended validation. And within this group, you can also choose between a single FQDN certificate, a SUN certificate, and a wildcard certificate. What is the difference between the three? A single domain certificate only contains one FQDN in the certificate, the common name. That's all the scenarios we have worked for before. In a SUN certificate, you can add multiple domains. So you only have one common name, and in the extension, there's written down which other FQDNs are also covered by this SSL certificate. So you can use this SSL certificate on more than one server. You can use it on the server fms.theclipfactory.com and also on the server webdirect1.theclipfactory.com and webdirect2.theclipfactory.com, and also on the website www.clippy.com. A wildcard certificate is a certificate with an asterisk in front of it. It validates all subdomains of theclipfactory.com. So you can install it on multiple servers. You can have www.theclipfactory.com, fms.theclipfactory.com, and so on. But only for that domain, not for a subdomain. So ws.internal.theclipfactory.com will not be validated. A wildcard certificate is very efficient and very handy if you have a lot of servers to install. But if you need an extended validation, because of the rules, you cannot buy a wildcard for this. We spoke about the three kinds of certificates, but in fact there are only two kinds of certificates, because a single domain certificate is in fact also a SUN certificate, having the top level domain in the extension and the common name in the extension. So internal certificate authorities often request to have already that SUN extension in the CSR, while the certificate authorities where you buy online do that for you during the buying process. So how do you solve it? How to generate a CSR certificate with a SUN extension? You can do that with OpenSSL. First, you create a small file, a config file, that looks like the following, where you, and you can see it below, and the alternative names have a list of all your FQDNs that will be covered by that certificate. Next, you generate again the CSR file with the same command we have seen before, but with the additional option config to generate the CSR file with the SUN extension. Eric has now ordered an SSL certificate. But that does not mean he already received it. Before he will receive the certificate from the certificate authority, everything must first be validated. Depending on the kind of certificate you're buying, the validation process could be different. For the domain validation, there are most of the time 3 options. At the end of the process, you will obtain a code that you have to add as a TXT record to your DNS server. The second method is that you get a file and put it on the website linked to the FQDN. Of course, it should already have that website and it should be public. Third option is you can get an email sent to the whois contact of your domain or to one of the email addresses that's starting with hostmaster, postmaster email address of your domain. With an organization and extended validation, there are more steps that are happening. So you need to have a proof of existence of your organization. That goes often with a phone call. With some other validations, you have to provide paperwork, and it could take a while. Depending on the situation and depending what kind of certificate, it could take days to weeks. Erik obtained his certificate and is now ready to install the certificate on the FileMaker server. First, he uploads the certificate he received, his own leave certificate. Together with the leave certificate, most of the time you also receive the intermediator's certificate file. If this is not the case, you can download it on the website of your certificate authority. And the last 2 files we have to upload are the private key and the private key password. That's the one that we have generated on our own local machine or on the FileMaker server. So don't throw it away after generating it. You will need it here. It could be that you receive the SSL certificate in the wrong format. You could reissue your certificate at the certificate authority website, but in most cases this is not needed. With OpenSSL, you can convert your wrong format to the correct format. So these are the commands, or 2 example commands We'll start again from the beginning of the slide. It could be that the SSL certificate is delivered in the wrong format. There are multiple kind of standards for SSL certificates, and we need them in the PEM format. To solve this, you can reissue it at the certificate authority, on the website of the certificate authority, or you can convert it with OpenSSL. Here you can see 2 commands to convert a format to the correct format that FileMaker Server requires. So we have the P7B format and the PFX format. Erik has now uploaded the SSL certificate to the FileMaker server and now reboots the FileMaker server to get it active. Erik has successfully installed the SSL certificate on the FileMaker server. You would think he is ready, but is he really ready? During his exploration phase, Erik stumbled on an article on the Gladys community. In his article, someone mentioned that he got a security audit on a FileMaker server and that he had a bad report with some questions in there. The remarks were that the SSL TLS server still supports TLS v1, that it contains weaknesses, that the server is vulnerable, that there could be a reason for a man-in-the-middle attack, including beast and poodle attacks. What are poodles and what are beast attacks? In addition, multiple standards organizations, including NIST and PCI, have declared that TLS v1 is no longer supported. So does it mean that the FileMaker server is not compliant? And then the complete madness starts. All kind of technical terms like TLS v1.2, Diffie-Hellman, block ciphers, AES, GCM, CBC mode, SH256. His head is spinning. Where is he talking about? Where was that IT department talking about? They're speaking a completely different language than the Claris developer. So, oh no, Aries is back to square one. He's still hesitating to bring his FileMaker server to the cloud. What should I do now? Let's talk about TLS and figure out what the IT department exactly meant with all these technical terms. Is it really true that the FileMaker server was insecure and using old TLS versions? Let's figure out. The first thing that you have to know is that there are multiple versions of SSL TLS. You have SSL 1 to the latest version TLS 1.3. The older the versions, the more security issues in there. The current most used version is TLS 1.2. Encryption works with keys. And TLS is working two kinds of keys, symmetric keys and asymmetric keys, and uses a combination of this. What is a symmetric key? Well, a symmetric key is that you're using the same key to encrypt and to decrypt a certain message or a certain data. Examples are RSC4, DES, 3DES, AES. These are methods of symmetric key encryption. Second, you have asymmetric keys. What does it mean? You don't use the same key to encrypt and to decrypt the message. So to encrypt the message, you use a private key, and the public key is used to decrypt it. Terms you find back is RSA and Diffie-Hellman. These are exactly the terms we have seen in the message from the IT department. TLS is using a combination of encryptions. This combination is called a cipher suit. Some cipher suits are safe, some are unsafe. Cipher suits that are safe today could be unsafe tomorrow. With this information in mind, let's have a look how the FileMaker server is secured. What version does FileMaker server support? And which cipher suits are used? Are they currently safe? To understand better the security model, you have to look to the several components of the FileMaker server. There are two main components that are serving directly data to the users. First, you have the FileMaker server, which serves all data for FileMaker Pro and Go, and you have the XDBC traffic. Second, you have the web server. The web server is serving data over port 443 for WebDirect and streaming containers and the other web components, and port 16,000 for the administration of the FileMaker server. Let's have a look to each individual component. First of all, let's have a look to the FileMaker server and XDBC data traffic. This traffic is encrypted by TLS 1.2 and modern cipher suits. So this is okay. Be aware for older versions. Older versions are using older versions of TLS and could be vulnerable to attacks such as Poodle attack. So be sure that you're using the latest version of FileMaker server. Now let's have a look to the web server. And for the web server, we have to look to several components or to several versions of the FileMaker server. First of all, you have macOS and Linux. macOS and Linux both are using the Apache web server. All settings are already set by the FileMaker server installer. so TLS 1.2 is enabled, and a wide set of cipher suits, modern, safe cipher suits. You can find these settings in text files on the Apache web server. It could be that in your organization some cipher suits should be disabled due to policies. You can manually change that in the files mentioned in this slide. Be aware that you have to do it twice. There's a separate setting for port 443 than for port 16,000. How do you know, in fact, which settings are safe and which settings are not safe? There's a good website from Mozilla. Mozilla has the SSL configurator, where you can check if your settings are set correctly. Second, on Windows you have Internet Information Server. So what are the settings there? Let's have a look to the documentation. The cipher type is controlled by the Windows operating system and an IS web server. So it depends a little bit on the version of Windows, how that has been set up. It is not set by the FileMaker Server installer, so you have to configure yourself. How do you test your TLS settings? Let's have a look. There are several websites that are offering a service to test your TLS settings and are telling you if you have a safe and compliant installation or not. One of them is ImmuniWeb. ImmuniWeb is easy to use because it shows immediately if you are compliant with certain compliances such as PSI DSS, NIST, HIPAA compliance, etc. This is a default installed FileMaker Server on the Windows Server 2019. So we got a score of C, which means not the best score. Second reference in testing TLS is SSL Labs. And we did some benchmarking and test results with SSL Labs on random FileMaker servers on the internet. And depending on the version of the Windows server and the standard settings that are rolled out, we have a score between the F and a B. If we check FileMaker Cloud, then we get an A+ rating. That's something you want to have on your own FileMaker server as well, in the on-premise server. So how do you achieve this? Let's have a look to the documentation of Windows. You have to change it in the Windows registry. We all know changing things manually in the Windows registry could be hard. Luckily, there is a software written by Nartak where you can, in the user interface, easily change the settings of TLS. This is how the interface is looking like. And you see that you can enable and disable the different versions of TLS, use ciphers and hashes, and set certain combinations on or off. You can also enable and disable the cipher suits. I know we are not specialists in this. Lucky enough, Nartak comes with some templates, and you can easily choose one so that you are compliant with certain compliances such as PSI or others. After applying the changes and rebooting the machine, your new machine could also have an A+ score. Erik has now successfully installed the SSL certificate and set up the proper TLS configuration on his FileMaker server. But what should we remember from this session? First of all, if you want to buy an SSL certificate online, you need to own a public domain name. Second, TLS SSL is more than just encryption. We have seen how you can buy an SSL certificate and which kind of SSL certificates exist. We also have seen that standard TLS settings is not enough. You have to patch them from time to time. Use always the latest version of FileMaker Server and operating system to stay secure. And remember, in FileMaker Cloud, everything is already done for you.